Hey, so this is the Fun Farm Tech here, bringing you another practice test. We'll go over 10 questions. A lot of these questions are going to be more challenging as we go. So I pulled these questions from two of the practice exams that I use for my practice test. So in this review, I've used 10 questions of the 141 questions that I have for the practice test number 1. In practice test number 2, it looks like I have another 143 questions. So by signing up for the class, you get 2 practice tests with about 140 questions each. So if you're interested in signing up for the class, go ahead and shoot me an email at thefarmvilletech@gmail.com. Those are only 2 of the tests. We also have 2 more practice tests, or 1 more practice test that doesn't have that many questions, but it definitely goes over more material. So definitely the more you practice, the better you'll get. Those are just the practice parts of the class. We also have, if you've seen my other YouTube videos, you'll see that I also have PowerPoints. There's 8 PowerPoints that I go through, break down things really nice and easy. So that should help as well. So the first 2 questions are this. So the first question is, if the pharmacy technician is to prepare 2 liters of a 6% betadine solution for stock, what volume of a 10% betadine solution would be used if it is mixed with distilled water? Now, I'll go ahead and do a quick pause so you can go ahead and pause the video and try to work it out yourself. That'd be best. And then once you figure it out, or if you want to check your work, you can go ahead and hit play and continue to watch me do it. But I'm only going to pause for probably about 1 to 2 seconds between the questions. So, go ahead and pause. All right, so I hope you guys got the right answers. What this is going to be testing right here is this is going to be testing your knowledge of dilution. All right, so when you're working with dilutions, so the formula that I like using is going to be your IV IS equals FV FS. Now, what does the I stand for, you might ask? The I is going to stand for initial. The V is going to stand for volume. And S is going to stand for strength. And then F is going to stand for final. All right, so if you have your initial volume and the initial strength equals the final volume and the final strength, you need to look at the problem and find out, all right, what information do they give you? So your final volume is going to be 2 liters and your final strength is going to be 6%. And let's go ahead and put these in parentheses. All right, so then we need to know, the question is, what would be used if it is mixed with distilled water? So they want to know how much, what volume is to be used if 10% of betadine is used. So you have the initial strength. So the initial strength is going to be 10%, and you want to know X. Now what you're going to do is you're going to multiply those together, and when you multiply those together, that's going to give you 12. And then to get X by itself, you're going to divide each side by 10%. So when you divide each side by 10%, that's going to give you 1.2 liters. Okay, 1.2 liters. Now, if we wanted to convert this to milliliters, how would we do that? Well, there's a few ways you can do it. So there's going to be 1,000 milliliters. So 1 liter holds 1,000 milliliters. So if you multiply those two together, then you're going to have 1,200 milliliters. So you'll need 1,200 milliliters of the 10% solution to get 2 liters of a 6% solution. So the next question is going to be, the pharmacy refrigerator must be maintained at which of the following temperatures? Well, we know that 32 degrees is freezing. So anything below 32 degrees isn't going to be refrigerator because you're not going to want to freeze things in the refrigerator. So we know that A is not an option. And if we also think about how cold it is in the actual pharmacy, chances are it's going to be between 59 and 86 degrees. So that's basically room temperature. So it's not going to be that one. So basically your 2 options are going to be B and C. If you know what temperature a refrigerator is supposed to be at, you'll know that B is the correct answer. All right, so the next two set of questions, the first one is going to be how many milliliters of a 2.5 milligram 5 milliliter stock solution will be needed to prepare 3.5 liters of a 2 milligram liter solution. This is going to be another dilution question. So with the dilutions, we're going to have IVIS equals FV FS. So what's going to be the initial volume? The initial volume is going to be unknown. So that's going to be our X, and our initial strength is going to be 2.5 milligrams over 0.005 liters. So why do we convert the 5 milliliters to 0.005 liters? Well, if we look at the units over here, that's how that is. So we want to make sure the units are going to be the same. So by converting the 5 milliliters to 0.005 liters, that gives us the same units as what we want. So we have the initial volume times the initial strength equals the final volume, which is 3.5 liters, times the initial strength, which is 2 milligrams per liter. So when we multiply those two together, we'll have 7 milligrams per liter equals X times, and then when we divide those, we're going to have 500 milligrams per liter. And then we divide both sides by 500. And when we do that, X is going to equal 0.014 liters. And when we convert that to milliliters, that's going to be 14 milliliters. So we are going to need 14 milliliters of the 2.5 milligram 5 ml stock solution to prepare 3.5 liters of the 2 milligram per liter solution. The next question is, a universal claim form is used for A, insurance fraud, B, insurance billing, C, insurance policies, D, insurance theft. All right, so that one is going to be B, insurance billing. And that is just another one of those things that you're just going to need to know. If morphine is infused at a rate of 0.8 milligram per hour, how many milliliters of morphine sulfate 2 milligram per mil would be needed for 12 hours of analgesics? So the first thing that we're going to need is we're going to need to know how long 2 milligrams will last for. So the way that we're going to do that is we know that 0.8 milligrams will last for 1 hour. So 2 milligrams, line equals line, equals X amount of hours. When we cross multiply and divide, that'll give us X equals 2.5 hours. Then we'll take 12 hours that we get from right there and divide that by the 2.5 hours we received. And that'll give us 4.8 milliliters. The next question is 97.5 milligrams is equivalent to how many grains? Well, we know that 1 grain equals how many milligrams? 1 grain equals 65 milligrams. So that's going to be our known. So 1 grain equals 65 milligrams. We want to know how many grains are 97.5 milligram. So when we set up this way and we cross multiply and divide, that'll give us 1.5 grains. And that's our answer. So the next question reads, how many 250 milligram doses are contained in 5 grams of cephalexin? So we know that we have two different units right here. You see how that's milligrams and this is grams? We want to convert one of them to the other units. So 5 grams is actually going to equal 5,000 milligrams. And we want to know how many doses are in 5,000 milligrams. But we know that 1 dose is 250 milligrams. So when we cross multiply and divide that way, that'll give us how many doses are in 5,000 milligrams or 5 grams. So the answer is going to be X equals 20 doses. The next question reads, which of the following is the correct method for reconstituting ampicillin suspension 15 milligrams? Well, we look, add entire contents of water and hit the bottle against the counter. Well, that's kind of silly. So if you ever see something that kind of has a silly suggestion in it, that's typically going to be wrong. That's them saying, haha, you should know that that's not the answer. So shake the powder to loosen, then add the water in divided portions. That sounds reasonable. C, shake the powder to loosen, then add the water all at once. That doesn't sound as good as B. What about D? Any of the above methods are acceptable. Well, we know that A is not an acceptable answer, so D is not the correct answer. Now, why do we want to do it in divided portions? Well, if you do it in divided portion, it helps mix it up equally. Whereas if you do the water all at once, you may still have some powder chunks somewhere in there. So it's not going to be C, so the answer is going to be B. Shake the powder to loosen, then add the water in divided portions. All right, so this next question is probably going to be one of the more challenging ones. So go ahead and pause and see if you can do it by yourself. So the question is asking how many 100 milligram capsules will be needed to make a 3/4 liter of a 1 to 50 solution. So we know that one capsule is equal to 100 milligrams. Now we're going to want to convert the 3/4 liter into units that we usually like. So we like milliliters. So if we convert the 3/4 liter to milliliters, that's going to give us 750 milliliters. So what does the 1 to 50 solution tell us? Well, we know that it's going to be grams and liters. So we're going to have 1 gram equals 50 milliliters. And that's what this tells us right here. But now we have 750 milliliters, and we want to find out how many grams we're going to need for the 750 milliliters. So when we cross multiply and divide, that's going to give us X equals 15 grams. So to make 3/4 liter of a 1 to 50 solution, we're going to need 15 grams. And we know that 1 cap equals 100 milligrams. We want to know how many caps out of 1,500 milligrams. Now, why is it 1,500 milligrams? Because it was 15 grams, but we wanted it to be the same units. It's asking about the milligram capsules, so we just change that to the milligrams. So when we cross multiply and divide, that gives us X equals 150 capsules. So we can make 150 capsules with this information right here. All right, and the last question is just going to be the DEA number calculation. I have a wonderful video that goes over how to do the DEA numbers, but go ahead and pause it and try to do this one yourself. All right, so the answer is C. So how do we do this again? Remember, we add number 1, 3, and 5, and add the numbers, the second, fourth, and sixth number. So if we do that, 1 plus 5 plus 8 is going to equal 14. And the second, fourth, and sixth number, that's going to equal 17. We multiply the 17 by 2, which gives us 34. And then we add these two numbers together, which is going to give us 48. And the last digit is going to be 8. So we know that C is the correct answer. Make sure if you like this video, make sure to like and subscribe to the YouTube channel for future practice problems and future notifications about the pharmacy technician exam. And if you need any specific help, please feel free to email funfarmtech at farmvilletech@gmail.com. Thanks and happy studying!